Have you ever put a bowl of soup in the microwave, waited 2 long minutes, and then burned your fingers on the bowl, only to find the soup inside is still ice cold? Or have you ever wondered why heating up a simple slice of pizza can sometimes turn the crust into a rock-hard piece of cardboard? Did you know the magic box sitting in your kitchen right now was invented completely by accident, all because a scientist had a melted candy bar in his pocket? In this video, you will learn exactly how this magical kitchen appliance actually works. You will learn why it makes the water inside your food dance, why it completely struggles to melt ice, and why putting a fork inside is a terrible, dangerous idea. Let us start with the absolute basics. What exactly is a microwave? Well, it is not just a clever name for the box on your counter. Microwaves are actual, invisible waves of energy. They are floating through the air right now. Think of them like the light waves that come from a light bulb, but there is a difference. Your eyes cannot see them. Or think of them like the radio waves that bring music to your car. Microwaves are just like radio waves, but they are much shorter and much more energetic. Imagine you are standing at the beach. You look at the water and see small, gentle waves slowly hitting the sand. Now imagine a storm rolls in. Suddenly, bigger, faster waves are crashing into the beach, one after another. The waves inside your microwave are like those fast, high-energy crashing waves. They are a type of electromagnetic radiation. Now wait. Do not let the word radiation scare you. This is not the dangerous, glowing green comic book radiation that turns people into superheroes. It is totally safe, everyday energy. In fact, it is very similar to the invisible Wi-Fi signal that is connecting your phone to the internet right now. So how do we get these invisible, crashing waves inside a metal box? It all starts with a heavy, hidden part in the back of your oven. It is called a magnetron. You can think of the magnetron as a whistle. But instead of blowing air to make sound, it uses electricity to blow out microwaves. This brings us to a crazy story. Let me tell you how this machine was discovered. The year was 1945. An engineer named Percy Spencer was working in a laboratory. He was building radar technology for the military. Radar machines use massive magnetrons to send out waves to spot enemy airplanes. One day, Percy was standing right next to an active radar machine. Suddenly, he noticed something felt very strange in his pants pocket. He reached into his pocket. He had been saving a peanut butter candy bar for a snack later, but when he pulled it out, it was completely melted. It was a messy, sticky, warm paste. Here is the crazy part. Percy was not hot. The room was not hot. There was no fire, but the candy was cooked. He realized right then and there that the invisible radar waves had heated the food. He tested it again the next day by bringing popcorn kernels into the lab. The radar popped them perfectly. That exact same radar technology is sitting in your kitchen today. The magnetron takes regular electricity from your wall. It transforms that electricity into powerful microwaves. Then, it blasts those waves directly into the cooking box where your food is waiting. Okay, so the magnetron blasts waves into the box. But how do invisible waves make your leftover spaghetti hot? Why does the food get hot, but the glass plate underneath it stays mostly cool? This is where the magic really happens. It all comes down to water. Almost all human food is full of water. Even dry-looking food like bread or chicken is packed with tiny water molecules. You need to think of a single water molecule like a tiny, invisible magnet. It has a positive end on one side and a negative end on the other. When you turn on the microwave, the waves wash over your food. These waves have their own strong magnetic fields, and these fields do not just sit still. They are constantly flipping back and forth. Up, down, up, down. They flip millions of times every single second. Because the water molecules inside your food act like little magnets, they try to follow the flipping waves. When the invisible wave goes up, the water molecule flips up to match it. When the wave goes down, the water molecule quickly flips down. Imagine a super crowded dance floor at a party. Suddenly, the DJ plays the fastest, craziest song in the world. Everyone on the dance floor starts spinning around, bumping shoulders and crashing into each other. That is exactly what your water molecules are doing. The microwaves force them to spin around and bump into each other 2.4 billion times a second. All this high-speed spinning and crashing creates friction. Try rubbing your hands together really fast right now. What happens? Your hands get warm. That is friction. Inside your food, billions of water molecules are rubbing together. That friction creates heat. That heat quickly spreads through your meal and suddenly your dinner is ready to eat. But here is the part most people get completely wrong. You have probably heard this your whole life. People say microwaves heat food from the inside out. Right? That is why the middle is hot. Wrong, it is a massive myth. Microwaves absolutely do not heat your food from the inside out. In reality, microwaves can only push into your food about 1 or 2 inches. They hit the outside layers first. If you are heating up a huge, thick block of frozen lasagna, the microwaves only heat the outer edges. Then you have to wait for that hot outer layer to slowly pass its heat to the cold inside layer. It works just like a regular oven. This is exactly why the outside of a frozen pastry can be burning hot like lava, while the very middle is still frozen solid. The invisible wave simply could not reach the middle. The outside trapped all the energy. And speaking of uneven heating, have you ever wondered why your microwave has a spinning glass plate? Why does the food need to turn in circles? Think about standing in front of a campfire on a freezing cold night. If you just stand perfectly still, the front of your body gets super hot, but your back is still freezing. What do you do to fix this? You slowly spin around in a circle so your whole body gets warm. The waves inside your microwave do not spread out perfectly. They bounce wildly off the metal walls. In some spots, the waves crash together and double their power. This creates a hot spot. In other areas, the waves miss each other completely. This creates a cold spot. If your food sat perfectly still, the hot spots would burn your food black. The cold spots would leave it frozen. The spinning plate acts like you turning in front of the campfire. It moves your food through the hot and cold spots so everything cooks evenly. Now we must talk about the golden rule of the kitchen. Never put metal inside the microwave. No metal forks, no aluminum foil, no plates with shiny gold paint. But why? What actually happens? Think of a bathroom mirror. When you shine a flashlight at a mirror, the light bounces right back at you. It does not go through the glass. Metal acts exactly like a mirror, but for microwaves. The invisible waves cannot pass through metal to reach the water in your food. Instead, they bounce off it violently. But it gets much wilder than that. Remember how microwaves force things to move? Well, metal is completely full of loose particles called electrons. When microwaves hit a piece of metal that is thin and sharp, like the tiny prongs of a fork or crinkled aluminum foil, they push all those electrons right to the sharp edges. The energy builds up fast. It gets so crowded at the edges that the electrons suddenly jump through the air, desperately looking for a way out. When they jump, they create a tiny lightning bolt. You see it as a bright flash or a spark. If that spark hits a piece of dry food or a paper towel, it will instantly start a fire in your kitchen. So always save the metal for the dishwasher. Wait, you might be thinking, the inside walls of the microwave are made of metal. Why do they not spark? Because the walls are thick, smooth, and perfectly flat. There are no sharp edges for the electrons to jump from. So there you have it. Your microwave is not just a magic box. It is a brilliant machine that blasts radar waves into your kitchen to make billions of tiny water magnets dance until they get hot. Pretty amazing, right? I want you to try a practical experiment today to see this science for yourself. And do not worry, this is completely safe. Take the spinning glass plate out of your microwave. Now take a large piece of cardboard and cover it completely with small marshmallows or shredded cheese. Put the cardboard flat inside the microwave. Turn it on, but only for about 10 or 15 seconds. Watch it closely so it does not burn. When you take it out, you will notice something incredible. Only certain spots of the cheese or marshmallows will be melted. The rest will look completely untouched. By stopping the food from spinning, you just created a real-life map of the invisible hot spots in your exact microwave. If you loved discovering the secret science hiding right inside your kitchen, hit that subscribe button right now. We post videos every single week to help you understand the invisible world around you. Subscribing tells the YouTube algorithm to send more of these brain-boosting videos directly to your feed. Plus, we would love to have you in our community. Before you go, leave a comment below telling me the weirdest thing you have ever accidentally exploded in the microwave. We have all done it. Mine was a hot dog that blew up like a balloon. Thanks so much for watching. Do you want to know how your fridge really works? Click the video on your screen right now to watch it next. Subscribe, see you there.